So welcome to session 2 for design pattern course. Today I am going to present for you two patterns and a little bit about myself. My name is Irina. I'm a lead software engineer at JPMorgan Chase today, and I ex-Revolut and I ex-Yandex, and I built systems to support 45 million clients. So right now it's even more. And overall, I'm sharing with you experience from my career. So something that I've learned for all these 10 years, and I'm reflecting my experience from my career. So that's reflection on my own experience. Yeah, so for those who joined our first session, what benefits do you remember from design patterns? And it's also a good question for those who joined us for the first time, because you definitely felt like there are benefits from learning design patterns. So could you raise your hand, post something in Slack, in our meeting channel, or like share somehow your thoughts? Don't hesitate. Yes, Anna?
First of all, sorry for my English. Pattern design helps us to create a system which is very will be stable and easy to maintain and easy to develop because of this template of creation is really good for editing and for developing, just because for improving, just because it's really how to say it, really easy to maintain because of good structure.
Perfect. Yeah, it's good answer. It's correct. I agree with it. Julia?
Hi everyone. I wasn't able to join the first lesson, but I did read the book and I really enjoyed how once you understand design patterns and everyone else understands it, it's a great way to improve communication. And it made me realize that I don't spend enough time on the actual design planning, and that I'm very quick to just try implement and get things out the way. But definitely made me think that if everybody understood design patterns better, you'd have an easier framework to work through changes with everyone.
Yeah, thank you so much for sharing your thoughts. It's amazing. I'm really glad that you're telling these things. Yeah, I said the same. Also, today, 2026, I would like to encourage you to learn these patterns, because you now can generate code even quicker with all these generative tools and code assistants. But if you know patterns, you can do it even better, because now you can say like, okay, could you rewrite and refactor these things by using this pattern? And even after these sessions, I feel like you can play much more with patterns when you learn them, because now you can say like, okay, could you refactor this for some tools that you use, and you can see result as well. And yeah, you can more experiment right now with all these generative AIs that come in. So it doesn't make like patterns are not valid because now it can be generated, but it actually makes even more sense today, because now you can improve your coding quicker. But if you know patterns, you can do it even better. And it's true about exchanging context quicker between developers. When you know already how to solve similar problems, you can exchange ideas quicker. And the first ever implication of this pattern, as Anna mentioned, it's templates that allow you to solve the same problems that developers solved in the past. They already invent the solution, and you don't have to reinvent the wheel. So you just go and apply patterns that could solve your problem and make it more maintainable in the future. Okay, let's go for today's patterns. So last week we did strategy pattern. It's quite straightforward. And again, you can find this video for last week and follow up. Like it's inaccessible right now on YouTube. Now, today we're going to talk about observer pattern. So what example book gave us? There is 3 players in the system in the ladder station. We have there is a data object that tracks data like weather, and we would like to share it with sensors. So we would like, we collect data from sensors and we would like to share it with display. So we want to give to users different conditions as fast as possible, so they could bring it to very beautiful screen. So that's what's happening. Basically, we have conditions, and we could create 3 different templates, or we could do it even better. So we could say that we have an object that holds state, and we can say that we define one-to-many dependency between objects, and one object change state, it get notified basically, and we can collect updates automatically. So what observer patterns say is that we basically don't need to go by ourselves and ask every holder of information. In this case, it's our devices that collect metrics. Instead of it, we can be notified. This is the main idea, to reverse which one is notified and how we manage dependencies. The same idea you can find in solid principles, where we talk about dependency injection, and when we talk about inverted dependency, which is IND in solid principles. So when we look at class diagram, it looks like this. We have a subject that's going to register observers, and we have particular observer, which will be our data collection, metric collections, and we have some subjects that, we also, this diagram mentioned that we have interfaces, and the last session we talked that when we do clean low-level design, we're trying to do interfaces first and then their implementation. In this case, we have more flexibility, and with this important rule that say like programming for APIs, which is mean programming for interfaces. This is something that's also, it's a good clean design coding rule. That's why when you look at this book, you will see a lot of interfaces as subjects, as observer. It's all interfaces because we're trying to program for interfaces as much as possible. And I will share next how it's applied for system design world, something like this as well. Yeah. So, what is a design principle here? Strive for loosely coupled designs between objects that interact. Loosely coupled designs, what does it mean again? So when we come back to example, you could manage all these sensors, something as objects that you create and store and maintain the life cycle in the same service where is your display. Yeah. But these design principles say don't do this. And it's applied not only to Java as object-oriented programming language. And again, last session I was talking about that oriented programming language, which it became. But Now it's also applied to different languages. So if you program in Python, I know that people programming in Python tend to do model and put everything in this model. So when you programming, keep in mind this principle. And it's very interesting when I try to do like some things in Python, I was like, okay, I'm going to create few models. They're going to be independent as much as possible because that's how I already am thinking of design when I program in Java. So I basically start to create few models, few files. I put them in different packages. For me, it's the same in Java. So this is thing, like if you're not in Java world, you can still steal these principles and apply it to world of your programming because that still will make it so much cleaner, so much maintainable. And as I touched it, in the same way, I want you to quickly send a message in the chat what language you are programming right now, what language you are learning, like, or maybe few languages. Yeah, so it will help me also to navigate what exactly to share with you, where to emphasize. For example, right now I'm talking about Python. Yeah, I see Python. R and Python. My main language is perfect. Python, C++. Yeah, C++ is object-oriented programming language. They also have lambdas. So it's also making them more flexible now. Python, Go, amazing, Java, Python, Java. Okay, yeah. So basically the same as I targeted in Java and mostly in Python. So yeah, I will okay, TypeScript. Last session I got example for TypeScript, so I counted as well. So I'm going to add examples in GitHub with TypeScript as well. Yeah, perfect. A little bit what I shared in difference between languages. So these principles for object-oriented programming, while TypeScript is functional language, which is mean first-class citizen is function, which is mean you can create function without creating object. And in Java, you can't create function without creating object. That's big difference between these two languages. But I believe that design principles and clean code is applied for different languages. For us, it's an art how to figure out how to apply it to our language. Yeah, okay. So we're going to come back right now to this example. We say that there is observer and we basically create a method update. So that's something generic that we could find out. So we look at this problem, we think, okay, what is generic? What is generic they all can do for us? Basically, they need to send update. So that's how we come to idea of observer who have one method update. Yeah, and so this is another way to write this in Java. In this case, you have parameters of subject as parameters. And if you create new parameter, you don't have to update observer as an interface. And you don't have to update three observer implementation. So again, if you look at this example, if you look at code and how could you do this, this is where it saves you a lot of time when you use it for pattern observer like this. Yeah, this is how it will looks like. Current condition display. It's get parameters. So we know that subject has different parameters, right? If you look at examples in book, you find out that it's my own improvement on this example, because if you look at parameters like this, it saves you even more time. And at the end of the day, when you want to update something with humidity, you just get humidity from parameters. When you want to update conditions like temperature, you just get them from parameters, and you see this is different displays, but they have the same function update. So that's make it easier. Yeah. And question. I also heard of publish subscriber pattern. This was very important question for me when I read this book. And I was asking myself, like, okay, is it the same thing? Because it looks like I kind of subscribed on something, and I can get notification from this. And actually, not the same, but we're going to cover publish subscriber pattern soon. So publish subscriber is more complex pattern that allow you to do more classes to create subscriber, to like get notification, etc. And it's used in middleware system. But again, these patterns right now can be applied on system design. So I'm going to show it next as well. Now, I was thinking like, okay, what is the difference? The difference that because publish subscriber is so popular right now, I guess you heard about publisher subscriber. And basically, could you raise your hand if you heard about publisher subscriber as a pattern? Yeah, I see hands. Yeah, perfect. So my guess today that publisher subscriber, a lot of people heard, and they kind of confused when they see observer pattern, the same as me, basically. And the idea is this one just easier, subject and observer. It's easier pattern. And publish subscriber, it's today popular pattern is design, like system design pattern. So you use publish subscriber pattern basically when you use things like message queues, RabbitMQ, Kafka. You can think like, okay, this is my publisher subscriber pattern. And for this, why it's important, like observer pattern you still use in your programs when you want to collect metrics. You may want to collect how long code has been executed, how long request response has been executed. You may want business metrics. For this, you need to observe things that happened. And here, observer pattern basically Excel. So you don't need publish subscriber. You just need observers in your system. If you worked with distributed system where you need to do metrics and see what's happened, you maybe know what I'm talking about, because ideally you always want to have metrics, because ideally you build when you build real-time systems that working in production, working every day, every minute, every second, you want to have metrics, what were happening. So this is where we use observer pattern. And publish subscriber we use to exchange messages between different systems. That's the difference. I hope it's now it's a bit easier. This is a few words again about it. So observers, we want to be aware of subject, and subject can be something that indeed you do request, you do response, this is your subject and you want to know how long did it take. You want to figure out if it's like, maybe it's not optimal code base that you wrote and that's why it's taking so long, yeah. And also you can do publish with subscriber asynchronously, while observing you want to do it synchronously, because you want to have results immediately, right here, right now, about what's happened in your system. And a good example to this one that I shared is when you like collect few business metrics. It could be your customers who do shoppings, and you want to see different categories. And you want to collect when you see that some category has been triggered, you want to collect it as a metric. So, and you may want to collect it in real time to see like if all yeah, if all the resources that you use working right now. So that's kind of popular when you want to track real-time metrics. So classic example, observer. Again, if you look at it, this is our data, and this is our subject. This is implementation of class diagram that we saw before. This is exact implementation. I'm not going to stop on this today, but I'm just going to share that there is another resource where you can consult about design patterns. I like it. It's Refactoring Guru, and I call it Raccoon Book. I'm going to share a few. You like that I'm calling it Raccoon Book. Yeah, thank you. I'm going to share with you example in Python, how it's going to look like in Python, because you already seen it in Java anyway. So we're going to create product, and we're going to attach, detach, and notify our customers about our product. In this case, again, we have observer this method update, and we have customer who would like to receive an update. So if you buy laptop, which is product laptop, or phone, which is product phone, we just want to attach our customer and attach our different customers to our products. And then we can set discount, and that's how our customers get notified. So that's very simplified example. That doesn't mean like in production we really will write it like this, but it's very good example how patterns is working. And again, where you would use it in production, you would use it with metrics to collect metrics and to also, yeah, to do these things. Now I'm going to touch a little bit public PubSub. I call it PubSub pattern in system design. So where you can find it when you design systems, and you can reflect on your own experience if you've seen it before. And first of all, I would think about database. So triggers in database, something that's basically trigger changes in different tables or some scripts if something have happened. So that happening with this kind of idea of PubSub implemented. Webhooks, we may work a lot with webhooks when we design services, and this is kind of like, I'm not going to come to you to get notifications from you. I'm going just give you webhook and you notify me. So this is the idea of webhook. Events and message queue, as I said, RabbitMQ, Kafka, a very good example of PubSub's pattern. And also, as I said, monitoring and alerts in distributed system. It's both. It's when you implement it in code base, you do it for observer pattern, but then how it works, then how like servers subscribe on these updates, it's already PubSub pattern. Yeah. So triggers on table, it's SQL or PLSQL. Not sure like how popular it is, but it was very popular when I worked on my first work. We did a lot of PLSQL basically. So if you know these things, you can think about it as analogy. Webhooks, again, like it's an implication for distributed system. Here is explanation again, what is webhook. In this case, the subject is server or system that generates some events, and observer is the service that's listen to events for the one who wants to get update on this one. Example, if we do payment gateway notification service, we have e-commerce platform, it needs to get updates. And in this case, subject will be payment gateway, and observer will be e-commerce platform that listen to get payment confirmation. Yeah, so users make a payment payment gateway processed payment and completed it, and get payment, send payment succeed webhook to e-commerce platform. So e-commerce platform listening this webhook to this update, and then they change the status of order to like from payment to paid. This is kind of interesting example for this one. If you maybe heard about block byte go, this is also good examples to look at different patterns in system design, basically. And this is pictures that say the difference between polling compared to webhooks. Yeah, so in webhook, as we said, API gateway basically get results, while like with polling, payment processor always check payment service if it's ready. But in case of webhook, external payment processor just implement its webhook, my webhook.com payment stripe. So again, if you have any more questions, please ask me at the end of the session or ask me in Slack so I explain concepts if you have any doubts. More examples could be found if you think about what CI/CD is doing. Again, like it's notify about changes in repository, and that's how we can think about our CI/CD trigger our deployments or new build or to run tests, because something we did commit, we immersed it, and then there is webhook to get notifications. I hope it's now easier. So when you learned these things, could you raise your hand if you ever worked already with webhooks, if you feel that now this concept much more familiar with you? Yeah, I see hands. Yeah, good. Yeah, thank you so much for being here. Yeah, perfect. Yeah, I have one. Okay, I hope now it's easier for you. One example, when we can do hooks in Slack as well. You maybe heard about Slack webhook. And again, like if you want to get notification from failed build, the same, you can do notification as well. Now, if you go about publisher and subscribers, I can touch a little bit event-driven architecture. So in microservices, architecture used for service-to-service communication. And here we shifted from this book as a reference to low-level design. But one more thing I need to say is that these design patterns were created when it was monoliths. But today we live in microservices world. So basically we shifted from service-to-service communication in one monolith, in one big service, to microservices communications and interactions, because microservice is easier to maintain, deploy, it has its own team, and it has clear borders. So some ideas around these came to microservices. So service-to-service communication can be done via publisher-subscriber, and it's very popular today. Like whenever you don't need to get synchronously immediately, if you just need update, eventually, then you get through publisher-subscriber pattern. So that's called event-driven architecture. I don't know, could you raise your hand if you heard about it, if you worked with messages, message queues, etc.? Yeah, I see hands. So now you see, like, I'm really happy to see hands, because now you see like how these low-level design patterns go to higher level design patterns. So you see the journey of this. And when you go through design, you can use it, because right now it's popular also to design microservices and interactions between them. So this pattern, like whenever you can use asynchronous communication, you can save cost of dependencies. Oh, it's very interesting because here we come back to this principle. We come back to this one, strive for loosely coupled design between objects that interact. So when we go to microservices level and we design these services, instead of allowing them to interact with each other, we say no, because in this case, you depends on each other. We say if you don't need it immediately, if you can wait just for a little bit for event to be published, then we go for publisher subscriber pattern. So this is how it became very popular today when we actually do design for the system, when we do like interactions between microservices. I hope this definitely something you can take away with you. Let's look at this example. I love it. So I'm going to go and say like it's kind of event-driven architecture, but also this is what I was telling about, like loosely like having less dependencies. So yeah, I already asked you if you worked with it. I'm happy that if you had, but this picture defined it the most. And trust me, this is how it worked before Pattern was popular. So before we had a lot of interactions, and some sources also call it like microservices hub, because it's easy like to lose the track, like who depends on which one. Like service A, it depends, it would get update to service D, it should get back updates. It should go to service D, and it's actually should go to service E from service D. So this is much cleaner when you can use messages queues. Yeah, so right now it's very popular. Monitoring and alerts. So your subject here is monitored service. Again, for example, your microservice, it's something that you want to monitor. An observer is alerting system that could be a lot of things. Like very popular one is Grafana, and alert could be triggered in Grafana and send whenever you want, like a flag. So basically, you have kind of a chain of different tools that you're going to use, and all of this covering that. It's basically the same pattern that came in the beginning, and that's how we do it right now. So we do like observations from data monitoring alerts, and we use webhooks and publisher subscriber pattern to get these alerts, to get these events. Yeah, different things, CloudWatch, Grafana, New Relic, Datadog, all of these tools, they give you ability to monitor things. As I know that all these tools, enterprise tools, but if you worked in any of them, just let me know. Send message in chat if you touched on any of these. So I have a interesting comment that today client made me throw away my brand. Okay, interesting. We can talk about it. Let me ping me in Slack and we can chat about if I can help you with these things. Yes. So now service health monitoring system. This is a good example where I'm showing how this work if you worked again with distributed tracing and alerts. If we would draw the diagram of it, it's not that straightforward because you basically do streaming of data to different databases. And these databases will be picked up by Grafana service or by other alerting service. The popular things that I was using in all companies I worked with was Prometheus as storage of these metrics. So yes, I implemented all these tools, like how exactly to store and propagate metrics further. Yeah. Okay. Oh, I hope now it's easier, and I hope you've learned about observers and subpub patterns. And if you have any questions so far, do you want to ask anything before we go to next pattern? Okay, 1, 2, 3, 4, 5, solved. Okay, let's go to the creator pattern. Yeah, thank you. So a little bit about this book and examples. I like them because sometimes they build things you would never build it like this, and you may never even solve things like this. But when you see these hilarious examples, you can memorize. And again, like we discussed in the beginning about using the same language to interact with developers, with your colleagues, with customers, etc. So this is fine examples, but when you remember this, oh, how you would create a different amazing coffee drink, this was about decorator pattern. So I liked it because it's funny, because you can, it actually helps you to memorize complex things without being boring, as this book claimed. So they use this coffee example to explain decorator pattern. So what they say, oh, let's create an interface beverage. And I hope I pronounce it correctly, but let's do a lot of implementations, which is so many different coffee you could do with it. And also some coffees could be decaf because 2026, it's so popular to drink decaf coffee. And it also could be with soy milk. It also could be with semi-skimmed milk. Some people would prefer decaf with caramel. Yeah, so a lot of beverage. And if you do it in the way like it's written in the diagram, you end up with so many implementations of different strategies how you would basically prepare your drink. Yeah, that's interesting example. And now they put like you actually could wrap things, and in this case, yeah, the main idea is that estimate cost of these drinks becoming a nightmare, because we say that milk cost one thing, caramel cost one more another thing, mocha cost you another thing. So a lot of nightmare to calculate the cost at the end. And it could be also with whipped cream. But we can leverage here something that's called decorator pattern. And this is mean when you do just caffeinated drink espresso, it's dark roast. You do dark roast, it has one cost. You add chocolate and do mocha drink, it's another cost. If you put whip on the top, it's another cost. And there is a beautiful way to do all of this by having cost only one of only one ingredient. So this is how it looks like. We have a component we decorated with something, and we have implementation for decorator. And particular component, like concrete implementation, will get all benefits from decorators. Let's look at principle, which is open-closed principle, which is mean classes should be open for extension but closed for modification, which is mean instead of create it and modify beverage, you create classes that's open for extension. And this one is leverage hierarchy principle. And let's look at real life example. And this is implementation of HTTP requests, basically. Coffee was just to memorize the pattern, but when you look at real life, you can find it when you do HTTP request. So when we do HTTP request and we get response as well, we want a few things, especially when we do request. We want to authenticate that the person, customer, or service who do this HTTP request indeed have an access to our services with this authentication process. We may want to cache results if we have a lot of similar requests. We want to log our request, and we want to rate limit. And also, as I said, for publisher subscriber, we may want to record some metrics to monitor how long does it take. So it's also mean we want to do all of this, and we want to degrade our HTTP request with always functional. Example, e-commerce platform that integrates with, again, payment gateway and API. And with API sends payment request. The decorator could add the authentication header with an API key. And then it could log every request and response. And also, it could implement caching as well. So let's look how we will bring it in implementation. Yes, I will answer the question a bit later. I continue right now with decorator. When we look at API client, we say that this is an interface. Now, basic API client will just send request, nothing else, because then it will be, again, we don't want to have a lot of different implementations of client itself with different functional. Now, this is an important thing because we say that there is abstract class, and this is leverage hierarchy in Java as a language that have hierarchy. And now we say that this one going to implement our API client, but this one going to decorate it with some functional. So abstract class that's implement interface, it's again like we leverage hierarchy in Java here. Now, we can get wrapped client, which will be API client. And the wrapped client will send request. And this request, at the end of the day, will go to just send request. Let's look how it will go to be implemented. So authenticated API client. This is our decorator. And in this case, we get not only client, but also our token. We're going to check that our token is there. And this is the ones that we want to validate. This is correct one. So we get client, and we're going to use this client at the end of the day, but also we're going to validate token. Now, when we send request, we first of all add token, and basically I use here add token, but we could validate token here. And then we send request. And when we send request through super send request, it goes here, send request, just request data. You can experiment with examples on your own as well. Let me know if you need original code for them as well. Login. Now we want to add login. This extends decorator class. And now we have login API client. And this one, when send request, this one is going to log. At the end, it's going to send request, which could be just request, but it's called we already wrapped with authenticated API client, because we don't care which one here. It's just an interface. We hide complexity by having interfaces. Now, caching client, it's extended API client decorator again, but now it's going to check if cache contains our request, and if it contains, we just get a response from cache. That's it. While if it's not, we just continue with send request, and it could be logged, it could be authenticated whenever we want next. Yeah. Okay. Sorry for this. I needed to improve it a bit. I see that. Oh no, I think on this screen it's window. Okay. I'll put render. Okay. Okay. I have the same examples with dashboards on Python. And I also have here a reference to the book. Again, today I'm not going to go through this one. And yeah, as we're running out of time, I'm just going to go now in system design ideas about the creator. First of all, authorization service. You can put it as separate service before, but basically that's your one more service that's now authorized clients. Load balancer CDN. This is something that's wrapped basically your request before you actually get it, and do with this request whatever is needed. Put it on proper geographical location if it's CDN, get caches from there, or it's balance it on appropriate service that is ready right now to accept this request, or the authorization in the case you want. So here is a good example of decoupling. We've covered it in session 1 when you do payment service, but you say like different implementations could be different strategies, and we've put them to different microservices. And now we kind of decorate our payment service by putting in the front authorization service, or it could be today a popular thing is to put API gateway to accept requests from vendors, from third parties, from the internet. Basically, you hide everything in your private cloud, and from internet you get everything from API gateway service. You can play around it. So basically, when I say API get service, that's there is solutions on the market that can do everything for you: authorization, load balancing, etc. If you want to try to implement everything by yourself, you would go and do a few things, few different tools, where like you do authorization service, you do load balancer, and I've put it here for transparency. And even before you go to load balancer, it's a good idea to do CDN. Again, you can use ready solution, API gateway, that will do everything, all three things for you. But you may want to do everything by yourself as well. Depends. I'm going to ask if anyone worked with API gateways. If you did have to do some configurations, I feel like, yeah, if you touched this somehow. Yay. Okay, I have few hands. Perfect. So today you see again how it all applied to higher level things. Right, this is it. Yeah, we're almost in time. And today we covered observer and the creator. Thank you so much for hearts. Now I'm going to go through question about observer pattern. Grafana retrieve metrics using polling rather than subscribing to notifications. That case cannot really be considered an example of observer pattern with Prometheus with similarity notifications mechanism being more accurate example of observer. So good question. Thank you for asking this, and thank you for sharing that you understand these things. It's very important for us also to understand your experience as well, and it's brilliant that you're asking these questions. Now, so Polling is correct. It's polling metrics for us. In this case, so example of observer pattern is not how Grafana gets in it, but how would you write your code in your code base to collect metrics? Oh, well, at the end of the day for Grafana. But you still need to collect them in your code base as well, in your service. And if you have few resources, again, like it's popular when you do business metrics because you may have few classes that can generate these metrics. So for this one, you put, like if it's Python, it will be separate model that will do observations. And you can play around observer pattern because at the end, there are also one more, yeah, you can say that your observer knows which resources to update, like which metrics. Depends on your business logic. You send it to observer, and observer can have method update, and it resolves different sources for like different paths that you put in Grafana at the end of the day. And for your business logic, you say only just observer update. That's it, observer update. So this is how you can think about how this pattern could be here. Yeah. I hope it makes sense. Yeah, thank you so much. Another question: how would your team compose different implementation in your HTTP example? Yeah, okay. So you can have all these things, and I definitely missed slide where they all go together. But at the end of the day, you create you create a class that have this API clients, but you also create. Okay, good picture will be here. So we did all of these clients. Yeah, we did all this. Sorry, so I definitely missed this the end one. We did all these things, and at the end, it will be the same. Like your first one will be the same as cost dark roast. Here, instead of dark roast, it will be base API client with method send request. Then you created when you create another client, which will be authenticate client. You create it and you pass it in constructor, but this is your authenticated client, and the cost will begin send request. And then you get this one created, constructed, and you construct another object, which going to be login client. So you say new login API client, which get new authenticated API client inside, and that's get new base client inside. And then if you want to do caching client, it will be one more wrapper around this. You say new cache client, inside constructor, you say new login client, etc. If you look at how streaming buffers implemented in Java, it is the same. Like you will see how, if you want to write something in file in Java, it will be the same new stream buffer. Then instead new like something called buffer, inside new something called writer, something like this. So basically Java itself got implementation as a language of this decorator pattern. That's how they like, that is the way to streamline byte into file. And like, I think the reason that's because it could be file system, it could be another system, like it's not necessary, it's exactly directory and file system. It's flexible to do for different byte streaming at the end of the day, but mostly we did like files, just simple files. Yeah, at least what I've touched. So yeah, I'm glad that you got it. Yeah, thank you. Thank you as well. Okay, let me go to the last slide. So we're going to cover a few patterns next, and important, the Easter break. That's why next session will be not next week, but week after. Yeah, thank you. Someone also affected by Easter break. So yeah, next session will be after Easter break, which is 12th of April. I think it's 12th of April. We also do launch of mentorship program, so that's why we will post more. And the 7th April is deadline for mentorship program. So we're in good timing to continue week just after. Please join our Slack because I put these presentations there in our Slack. If you'd like to earn certificate, I'm going to publish a small quiz. It's based on book. It doesn't include system design examples or anything else. And for system design, we may do another separate course, but this one more like as a shift from low-level design to system design. Books that we are using as a resource, and the newest one is on the poster of this event. And yeah, that's it from my side. I'm going to stop presenting, and also, yeah, let me use this button.